Welcome to this explainer where we're going to dive into the absolutely colossal scale of global mining operations. I mean, think about the smartphone in your hand right now, or maybe the car parked in your driveway. We are looking at the massive, vertically integrated industry that pulls those very materials straight out of the earth and manages the whole shebang all the way to the end customer.
But when you really stop and think about the sheer volume of material moving around the planet every single day, a huge question naturally pops up. How in the world do these massive global entities track the environmental and social footprint of every single piece of metal they pull from the Earth? It's a monumental task, right? Well, let's dive into this by taking a close look at the SASB's sustainability standards for the metals and mining industry to see how this incredibly complex tracking is actually pulled off in the real world.
To make sense of all this, we're going to follow the actual physical flow of the business model. Our agenda today takes us on a journey right down the value chain. We'll start with the vertically integrated mine, move into extraction at the quarry level, then on to processing and smelting before examining the human element, and finally, we'll wrap up at wholesaling and global ethics.
Okay, let's get into it. Section 1, the vertically integrated mine. We're going to zoom out a bit on these global operations. You see, the larger entities in this industry, they don't just dig a hole and call it a day. They actually own the entire life cycle of the material. The business model essentially follows three massive steps: extracting the raw ores, processing and smelting those materials, and finally, wholesaling the finished metals directly to customers. It's this unbroken, fully integrated chain of custody from start to finish.
Now, to track sustainability across that massive chain, companies rely on the SASB standards, which are now part of the IFRS Foundation. This framework basically acts as a universal, standardized language. It holds companies accountable for their environmental and social impacts at every single one of those stages we just looked at.
Moving on to Section 2, extraction at the quarry level. This is really where the physical journey begins.
When you literally break open the earth, you are taking on some monumental environmental risks. A major hazard the standards focus heavily on is something called acid rock drainage. Basically, this happens when surface or subsurface water hits mining overburden, the leftover rock and soil, picking up heavy metals and becoming highly acidic. It is a highly toxic occurrence, and mining entities absolutely must disclose exactly where this is predicted to happen, how they're actively mitigating it, or where they are currently treating it.
Beyond water contamination, just the sheer volume of physical waste created by extraction is staggering. Under the standards, it's categorized strictly into four types. You've got non-mineral waste, so things like scrap metal and used tires. Then there's waste rock, which is basically earth with too little mineral value to actually use. Then we have tailings, which are the leftovers from the processing phase. And finally, highly regulated hazardous waste. Companies literally have to report the total weight for each of these categories down to the metric ton.
Now, out of all that waste, those tailings present a truly unique challenge. Managing these massive tailings storage facilities is absolutely crucial. I mean, a catastrophic failure of a tailings dam can release incredibly harmful materials right into local ecosystems and communities. So to keep tabs on this, the standard requires a remarkably strict inventory table. Entities have to track everything for every single facility: the construction method used, its current operational status, its absolute maximum permitted storage capacity, and its consequence classification if it were to fail. It's heavily monitored, for sure.
All right, Section 3, processing, smelting, and refining. This is where we turn that raw ore into actual metal. Once that ore is safely out of the ground, the very next step is processing and smelting. And let me tell you, this is incredibly energy intensive, and it can release some significant air pollutants. We are talking about carbon monoxide, oxides of nitrogen and sulfur, particulate matter, mercury, lead, and volatile organic compounds. The SASB standards actually require these entities to track all these specific emissions down to the exact metric ton. Staying on top of this with active management and new tech is absolutely essential for regulatory compliance.
And speaking of energy intensity, we really need to look at how power is consumed to run these massive smelting operations. Entities have to clearly and distinctly separate their emissions into two different buckets. Scope 1 emissions cover all the direct emissions, so this is fuel combustion right there on site for the mining equipment, refining, and their transportation fleets. Scope 2 emissions, on the other hand, are indirect. These are the emissions resulting from the huge amounts of grid electricity they have to purchase just to keep the plants running. Tracking both of these is the only way to get a true, complete picture of the operation's energy footprint.
Which brings us to Section 4, the human element. We've got to talk about the people behind this massive process.
Look, mining is tough, It's physically demanding, and it can be hazardous work. Because of that, the SASB metrics demand some incredibly strict accounting when it comes to labor relations and worker safety. Companies actually have to track the percentage of their workforce operating under collective bargaining agreements. They have to record the exact number of days left idle due to strikes or lockouts. On the safety side, they report detailed all incidents and fatality rates, total health and safety training hours, and, this one's really interesting, the near-miss frequency rate. This tracks unplanned events that didn't actually result in an injury, but easily could have. Oh, and all this data? It has to be separated out for both direct employees and contract workers.
But the human element extends beyond just the workforce to the actual regions where these mines are located. When you're operating on a global scale, these mines sometimes intersect with highly volatile areas. The standard defines an active conflict zone pretty starkly. It's any area with at least 25 battle-related deaths per calendar year. Entities are required to disclose exactly how much of their reserves sit right in these dangerous areas, which obviously highlights some major operational and security risks. Also, entities must be fully transparent in reporting the percentage of their reserves located in or near indigenous lands. This means formally recognizing populations with historical continuity, distinct languages, and deep, strong links to the surrounding natural resources. The standards focus really heavily here on an entity's due diligence practices, especially ensuring they are using free, prior, and informed consent processes whenever they make decisions that could impact these vulnerable communities.
All right, final stop, Section 5, Wholesaling and Global Ethics. Let's look at the corporate oversight.
This brings us to the very top of that vertically integrated model, the corporate level. To put a true value on their total global footprint, companies basically bucket their mineral assets into two main categories. First, you have proved reserves. These are practically guaranteed. The size, the depth, and the actual mineral content are incredibly well established through rigorous sampling. Then you have probable reserves. The degree of assurance here is a bit lower, but they can safely assume continuity between their points of observation. Every single risk metric we've discussed today has to be calculated against these two specific reserve classifications.
Finally, if an entity wants to sell these resources globally and maintain their access to those mining reserves, they have to maintain the highest levels of transparency. The standards literally require them to publicly disclose their production volumes, specifically within the 20 lowest-ranking countries on Transparency International's Corruption Perception Index. On top of that, companies must detail the exact management systems they use to prevent bribery and corruption throughout their entire value chain. They even have to account for project delays caused by non-technical factors. Think things like community protests or regulatory holdups.
So we've walked the entire quarry-to-customer pipeline together, from extracting the raw ore out of the ground, through the hazardous smelting phase, navigating complex human rights issues, all the way up to global wholesaling. Which leaves us with one crucial final question to think about. As vertically integrated mining continues to scale up to meet massive global demand, will these incredibly strict SASB metrics actually be enough to completely reshape investor trust? Ultimately, it turns out that radical transparency might just be the absolute most valuable resource we're pulling from the ground today.